Hello friends, I am presenting on behalf of my college this work entitled the Tolokatsin 2022 Sustainable Solar Oven. The first Tolokatsin solar ovens were designed and built more than 27 years ago. At CONSOLFOOD 2022 conference, the constructal evolution of these solar ovens was presented, showing the changes made to reduce the losses by reflections by changing the number of mirrors and the solar concentration, keeping only mirrors of simple curvature. In the search for greater sustainability, the most expensive materials used in these ovens were replaced to make them more affordable and easier to replicate in any small town with local materials. In particular, the stainless steel absorbers were replaced with fired and cured clay, and the aluminum mirrors could be replaced by inexpensive mylar films attached to actin support. Also, the number of mirrors was reduced. Here we report on the results of the manufacture and operation results with a ceramic absorber. The rationale is to use ceramics as a material with a much shorter and sustainable production chain, more fit for manufacture by small communities and artisans. Here, two solar cookers of the first model are shown with their containers open. Note the stainless steel trays with cooked meals inside them. These were rabbits, I remember. And this slide summarizes the constructal evolution of the Tolokatsin solar cookers. While its complexity increases, its performance improves. That's worth it? I think yes. Despite its apparent sophistication, it can be manufactured at home using basic tools, as is shown in these photographs. Here are our friends. We can manufacture the solar concentrator with simple cardboard and mylar, very inexpensive. This simple solar concentrator can reach more than 200 Celsius in a few minutes. The geometric concentration of Tolokatsin 2020 is that number, which can reach 222 Celsius, temperature too high to cook. If the three lower market mirrors are removed, the geometric concentration is reduced in 25%, but there is a saving of more than 30% of mirrors in the first stage of concentration, and we can still reach 189 Celsius with the same insulation conditions. It is worth removing them. The most significant innovation was the use of a new ceramic absorber. Red clay was used owing to its extensive use and experimentation in Mexico State. Its plasticity and resistance to cracks is much higher than other locally available clays, so it requires no fibrous consolidated materials. The red clay was thus well adapted to the slab molding and filling techniques, as well as metal inclusions without other extraneous material. A mixed slab mold technique allowed for a simpler two-piece 5 to 4 snow white dentistry plaster to water plaster mold. 3 surface treatments over the clay aimed to maximizing the absorbance in the ultraviolet and infrared range and were compared. 1, the hematite enamel to a black smoke, and 3, a commercial cobalt oxide with hematite lacquer. Finally, striations were added in all surface treatment for enhanced surface area and radiation absorption. Here we see the Tolokatsin 2023B and 2 ceramic absorbers, one in the oven's cavity and one spare one. The prototype was very, very successful, and we can reach much more than 200 degrees in a few minutes with this very, very simple solar oven. And that's all. Thank you very much. If you have got some questions, you can ask. Here is my email address, and I have time to directly answer the questions. Thank you very much.